Hello, good morning, team. My name is Asim. Welcome back to Cloud Asim YouTube channel. In this session, we will discuss about monitoring and observability. Right? In this concepts, if you are aware of the heavy application Netflix, Hotstar, how they are monitoring the real time to make sure their incoming traffic is being handled. Right? So behind this, there is a different concepts being handled by different organizations. Right? So in our use case, we are going to check how this monitoring observability comes to play. So for that, we are going to use Prometheus as a scrapping metrics application, which will scrap all the data. And for the monitoring dashboards and everything, we are going to use it Grafana, right? So in this concept, we are going to use Kubernetes cluster where we are going to deploy our Prometheus and Grafana within the Kubernetes cluster in order to get all the updates from our cluster metrics stating that what is the health of pods, what are the health of nodes, and what are the stateful sets being deployed, and different components we can go through this one. There are the different metrics like node cube state metrics, node exporter, right, cube components. There are the different components through which we can monitor using Grafana and Prometheus. Grafana is the application which will collect all the metrics, right? All the metrics through data scrapping, and it will store within its in a database. From here to have the visualization, we will use Grafana in order to collect that metrics and visualize as a dashboard in Grafana application, right? So in this case, we are going to go with the open source versions, and we will not only configure these tools inside the Kubernetes cluster, we will check how this being handled by Helm. So in this case, we will use Helm as a package manager to deploy this application inside our Kubernetes cluster, right? So behind this, we will see how Helm will work on, what are the charts, how we can fetch the secrets in order to access our Grafana dashboards through browsers. Okay. So you walk through this all video. Make sure to comment, like, and suggest us you required any improvements and how this video has been created. So my main concept is that not only install these tools within the Kubernetes cluster to explain you how this is being handled in the real time, how it's getting fetched, how it's ensure using demonstrate that at least one node exporter to be configured in available nodes. Okay, so let's go to the lab and we will do everything. Going to set up one new EC2 instance. I'm going to convert into that kind, and we will do everything from the scratch. And what we will do it, we will first review what is default metrics, what we are going to collect it. Then I'm going to use one application that is basically a voting app, which I'm going to deploy into a EKIN cluster, and we are going to monitor the performance and how we are going to get the real-time data and monitoring on the Grafana. Okay, so everything will be practical. This one, let's go and check how we are going to configure this. Okay. So first point, as I mentioned, we'll be switching over here, and I'm going to create one EC2 instance, right? For the EC2 instance, you required like powerful compute resources. So I can opt for going with the client cluster. Let's give it a name, cluster monitoring. So I'll be opting for T2 large because we required additional things to install EKS cluster where we are using kind to deploy our worker node and control panels, everything within one state, right? Ubuntu. Then here I'm going to check out and I'm going to select T2 large. Okay. The key pair, I have existing one. You can use it if you have, or you can create it. Here, I required minimum HTTP and HTTPS to be enabled for my kind cluster, right? And the storage, I need minimum of 25 GB. So you have to give it 25 GB. So everything look fine. So I'll be launching my EC2 instance, right? Then meanwhile, what I'm going to do it, I'm going to create one duplicate session where I'm going to access my, just a second. Yeah, I can edit this. I will update my EC2 instance IP address. So this is the latest IP which I have received for this virtual machine. So I'll be updating over here and I'm going to OK click it. So now I'm trying to connect to my EC2 instance which I have created. The first thing, when I'm going to log in, I'll be switching into root user because I'm the root admin. But if you want to work as Ubuntu user also, that works fine. So first thing, we need to update the pages. Okay, so I'll be updating the packages. Then afterwards, what I need to install, I need to install different on my EC2 instance, right? Because the prerequisite is that I need to install specific details, which I'm going to give it over here. So what I need to install, remember that we are using kind. So in the kind, we need to configure Docker. We need to install Docker. Then I need to install kubelet, if you remember our classes which we have seen. Then I need to install what additional I required. Kubectl is fine. I need to install Helm because I'm going to use Helm in order to install our Prometheus Grafana. Okay. ये तीन चीजें, these three things I required. Okay. So for this, I have a one shell script which we use in our last classes also, and I'll be sharing that script with you as well. Okay, so this is a shell script which I'm going to use to install Docker. Then I need to install kind also, right? So I missed out to mention over here, because we are going to deploy our Kubernetes as kind cluster, right? So I'll be using client official documents for that. Okay? So for this, I have created one already used shell script, which I'm going to use it. Okay. So what I'm going to do it, I'm going to create one directory and I'm going to name it as, let's say mkdir cluster. Okay. So I'll be migrating, moving inside this, so we can create all the documents related to it. Okay. I'll be using nano, and I'll be using install.sh shell script, and I'll be pasting over here, and control X, Y, and I'll be saving out. Okay. Magenta, using this shell script to install what kind. Before that, I need to install Docker. Then I'll be installing kubectl, and I'll be updating my caches. Okay, simple. So if you ls over here, you will be finding that there is a one install.sh, but it does not have executable permissions. So for that, I'm going to use shmd shell. We are using Linux commands, right? So install.sh. So if you check over here, you will be finding that you have, that is in the green color. That means we have executed permission. So I can use it install.sh. So what will happen? It will install Docker now. So if you check over here, it's stating that Docker is getting installed. Okay. After that, let's go down, then we will see it. So meanwhile, what we will do, we will go through this Docker session. Okay. So in the shell script, this is I'm updating the package. Then I'm installing docker.io. Then I'm adding current user to my Docker group. Okay. So what is my current user? My current user is root currently. Okay. So if you're working on Ubuntu, your Ubuntu will get added into Docker group so that you can execute your commands being a being Ubuntu user or root user. Okay. So after that, I'm installing kind, uh, using kind, right? I'm going to install the Kubernetes on our EC2 instance, right? So the kind is Kubernetes in Docker. Okay. So you are aware of the official document of that as well. So if I'm going to give it over here, right? Kind installation of Ubuntu, then you will be redirecting to the official document of kind. Okay. So installation resource. So these are the one which I have followed. Okay. So this is the one. Then afterwards, executable permission. Then I have moved to this library and the kind folder. Okay. If you are on the Linux, you need to execute this one. Okay. So this only been added into our shell script. So that's fine. Let's go and cross check what is a kind now. So if you check over here, it's finding stating that Docker version is installed, it's printing me. Kind version is printing me. That means kind is installed. Even I have installed kubectl. Okay. So if I'm going to use kubectl hyphen version, let's see what will print. So kubectl hyphen version. Let's say it's also giving it. So I can use only v. Let's see what will print. So cube hyphen kind version kubectl. Let's see what is there. Kubectl version. Let's see. So okay, it's stating that cubes ctl install, right? How about the kind? So let's print it with this one. So if we check over here, docker ps, so you're able to find that connection localhost refuse specify the ports being docker ps hyphen a. Okay, that's fine. So just I have installed the kind cluster, but I have not created the cluster, right? So that's fine. So Docker is installed, kind is installed, and I have installed kubectl. Okay. So Docker, if I'm going to print Docker PS, is printing me stating there is no container created something else, right? Stating that the Docker is installed. So if I'm going to give it Docker hyphen hyphen version, it will print me Docker as well. So it's stating Docker version is done. Okay. So that's fine. So now what we will do it, we will create uh, one cluster using our custom configuration file. For that, I'm going to use Nano, and here I have the file which I have used in the previous session as well. If you not remember, then you can check out over here. Okay. So let me go with over here. Let me see where I have kept that file. Okay. So let me go over here. Monitoring. Yes, install kind config.yaml, right? So if I'm open this file, this is a configuration file which I use it, right? So I'm going to copy this and I'm going to create it kind hyphen config. You can give it any name as per your convenient, but you keep the extension as .yaml. And bit I'll be pasting over here. What we are doing, we are going to create three nodes on which I'm going to convert one as a control panel, the remaining three as worker 1, worker 2, and worker 3. Okay, and by default I'm port forwarding 80 port and 440 port to my host machine, the container 2. That means the container which on which our working nodes and the control panel is working, that has been looped with our host machine. Okay. Host machine is easy to instance because the container, the worker nodes has been deployed into Docker container. Okay, the kind itself, it's stating that using the kind we can deploy our worker nodes in as a Docker container. Okay, so Control Y and exit. Now here I'm going to give it executor permission X in the kind, right? Then hit enter. So that's fine. So now the point of time I have given over here. So what I can do it, I can just use the command in order to create this. For that, we will be following the same command which I have used before, right? So if I'm going over here, what I'm going to do it, as I mentioned that I'm going to just create one cluster, right? I'm going to list a cluster using this custom file. Okay. So for that, I can give it a different name based on my convenient. Okay. So what I'm going to do it, I'm going to use the custom. Let me just give me a second. So I'm going to print it over here, stating cube. What was the command? Let me remember it. Okay, it's got it. So what I'm going to do it, I'm going to create this. So I'll be using kind create cluster. So create cluster. The create spelling need to be cross-checked. Create cluster. Then afterwards, I'm passing the name of this cluster so that I can use as a reference in future, right? So name, I'm giving name as Asim cluster. You can give it any name based on your convenient. Okay. After that, I'm going to call which configuration file I'm going to use in order to create my cluster. Okay. So for that, I can give it as a kind cluster name. So the name is over here, right? I'm going to copy and paste it so that I should not miss any single alphabet. Okay, kind create cluster hyphen name of the cluster which I'm going to pass config, then configuration. Please take this configuration which is exist on this kind config.yaml file. Hit enter and we will see what is happening. So if you check over here, you will be finding that ensure node image. So basically it's fetching the node image which is available on Docker Hub. Okay, Find has their own images available on the Docker Hub. Okay, so that images is being fetched. After that, it will create 4 containers, in which one container will be converted into control panel. Remaining will be converted into worker 1, worker 2, worker 3. Okay, as a prerequisite. So we'll wait for the few seconds. It will take some time. Okay. Meanwhile, what we can do it. Let's this one. We will go to our Helm and we will see that how we can install Helm. If you remember, I have given the Helm introduction. So Helm is a package manager for Kubernetes. So you no need to create the deployment of YAML file, let's say you want to expose your file, service.yml file. This kind of activities you don't need to create. Using the LM, you can deploy your application as a package manager. So it will package and you can deploy everything. So you'll get pre-built templates. Okay. So meanwhile, one more thing, what is there? This Prometheus and Grafana is given by the community version. Okay, this Helm community version, they are maintaining this repository where they have already created the templates YAML file of this Grafana and Prometheus. So if you check on this Helm charts, and I will take you drive for that as well. So if you check over here down, you will be finding that what is saying Helm must be installed to use the charts. Okay. So I haven't installed Helm. I will install now. Don't worry. So he's saying that refer to Helm documentation to get started. So we will install Helm. Then it's saying if you want to use this repository, you can use this link in order to take all the templates from this existing repository. Okay. So we will use this command to fetch this. And if you want to understand, okay, what are the charts is available within this, so that we don't need to write using the Helm repositories, right? For that, you can go with the charts and we will try to check on this one. Okay. See, these are the chart, pre-written charts are there, configuration, everything. You have CloudWatch exporter, you have Node exporter, you have MEM cache exporters, Redis are there, SQL are there, Prometheus is there. Okay. So these are already written templates are available. Okay. Using only few commands I can deploy over here. Chart.yml file, values.yml file, right? So everything is already written over here. Okay. So this will minimize our time in order to deploy our Prometheus and Grafana as a combine into the Kubernetes cluster, right? So if I'm come over here, it's stating that uh, one cluster is created, that is Asim cluster. The image has been fetched from Docker image, Docker up. That's fine. It is writing the configuration. One is control panel is converted. Storage class is defined. Is joining the worker nodes with our control panel. Basically master and slave concepts is being working over here. So it's saying you can use your cluster with context of Kubernetes info context client cluster. So let's see what is going to print it over here. Hit enter. So it's saying, okay, see, this is the local host on which this is Kubernetes API is working, kube system is working, namespace is created, different type of information is printing over here. That's fine, not a problem. Now if I'm going to check over here Docker PS, now you're able to find this over here. So what I'm going to do, I'm going to clear this and I'm going to minimize now, and I will zoom you, don't worry. Docker PS, now you're able to see that, see, there are the 4 containers has been deployed now. Okay. So 4 container, one is kind using the same image for this. And here are the container images. 3 minutes ago, 2 minutes ago, one is mapped with 8080, 397 and 6443. Okay. So that means these are the 4 containers which is running as a Docker container, in which one is converted as what? One is converted as your Docker, Kubernetes master control panel, and remaining 3 are worker. So let's say kubectl get pods, right? I will print. So it's saying that there is no resource found in default namespace. When I'm not passing any namespace over here, that means it is always referred to default namespace. Okay. So this you need to be clear, which we have already covered about this point. So kubectl and get ns, let's say what are the name servers are available. So if you hit enter, this is the namespaces. Name ns stand for namespace. So these are isolated environment in which you can create multiple application deployment, and it is isolated within that namespace. Okay. So if you check over here, it's stating that kube node lease, kubes public, kube system, these are related to your Kubernetes system. Okay. These are already been logged for Kubernetes system namespaces. Okay. If I want to check what is there exactly here, kube get pods get pods, I want to pass the namespace over here. What is the namespace? By default, all the pods, if you are aware of Kubernetes architecture, you're able to find that there are the core DNS works, etcd, which store all the information of cluster. Basically, it's a database for your Kubernetes cluster. And there is a kube API, kube controller proxy. As per our diagram which we have created, right? So it is taking, just a second, why it's gone. Where was the file? Let me cross check one more time. Okay, it's over here, right? So if you check here, we have some components that is running in the master control panel. That will be always in the namespace of kube system. Okay, so it's check here. See, it's finding kube proxy. Then you have etcd, and you have a different kube API server, Kubernetes API. So all are running in which pod? In the namespace of kube system. Okay, so up to now we have already done. Did I install Helm? So I haven't installed. We can use a package to install Helm as well. Okay, so up to now, I have done as a pre-request, I have deployed multiple things, right? What was the pre-request? I have installed Docker Prime cluster, and I've created one cluster. I have installed kubectl as well. Now I need to install Helm. So for that, I can go as just Helm. I can use Helm this one to install. So let's check it over here and copy and go over here, and I will install this Helm on this. Okay. After that, I'll be using this permission, executable permission, to my configuration file, the basically shell script, right? Which is over here. Okay. So if I ls, you're able to find one get helm.sss is installed. Okay. That is in the cluster. No problem. You can fetch this data into cluster or anywhere, but it will be installed as a global. Global, that means on the on EC2 instance, on the any directory, you can execute this helm commands. Okay. There is no worry for that. So here coming up, it's saying that please execute the shell script in order to install your Helm charts, right, on your virtual machines. Okay, so if you check over here and let me just print over Helm, so it's printing now Helm commands. That means Helm is installed. Okay, Helm chart is installed. Okay, so now basically it's giving me some of the like commands which I can use. Helm search, Helm install to install any charts to Kubernetes, Helm list, this kind of things. Currently, I haven't created anything, so this is anything using the header. I haven't installed anything. Okay, if I check over here kubectl also, you will be finding that I haven't installed any single pod to now. Okay, so pre-request is over here is nothing there, right? So what we will do it now, we will install a package manager. Sorry, we will install monitoring observability Prometheus and Grafana as a package manager, using Helm as a package manager. For that use case, what we can do it simply, let's first we will go and we'll create one namespace. So I don't want to disturb the default namespace. I don't want to disturb the existing any namespace which is available. So namespace is all this one. I have 1, 2, 3, 4, 5. Okay. So what I'm going to do, I'm going to isolate my monitoring environment, right? Everything in a different namespace. So what I'm going to do, kubectl create namespace. I will give it as monitor. Okay, you can give it any name, namespace of that. Hit enter. So it is spreading that one namespace is created. If I'm going to hit enter, you'll be able to find that one monitoring namespace is created 5 seconds ago. So now all the activity which I'm going to do it now for my monitoring Prometheus Grafana will be doing into this namespace. Okay, so that I can keep isolated configuration file within that namespace. Okay, accidentally I should not delete any configuration files. I should not delete any pods that is deployed for our monitoring and observability by for our Prometheus and Grafana. So for that isolation, I'm creating this namespace and I'm going to deploy this as well. Okay. So this is done. Now we will switch back to the document as I mentioned. Now, if you go over here, as I mentioned, Prometheus, which was the one, let me go to the README document. Helm chart Prometheus community. So it's stating that okay, use this Helm repo, and in order to get this repo and install on your virtual machine, right, on the Kubernetes cluster, basically. So what I'm going to do it, I'm going to fetch use this command, and no, I have used just a second, add homemade community Prometheus. This is the one, right? So okay, that's fine. So I'll be pasting over here and hit enter. So now what happened? Helm repo is one like using git command to in order to clone our repository from GitHub to our local machine, that is EC2 instance local currently our. So same way Helms also can be clone any repository available on Helm repositories. Okay, so we have cloned this repository. If I have ls over here, I cannot see that one, but basically there are the configuration file that has been saved. Okay, so now what I can do is I can use Helm in order to install these packages which I've fetched. So if I want to check over here what is there, so I need to use what I need to use Helm repo list. Okay, it will print me the list which I have just fetched from first fetched from my repo of Helms. Okay, so if you find over here stating that Helm Prometheus community one repo is cloned, and I have used this URL to clone this what you say this repo. Okay, so do we find, so we will use this repo to install as a package manager, that means charts, right? So for that what I can do it, usually the best practice is like when I'm updating my virtual machine, when I'm going to connect it always, right, sudo apt -y, the same as it is whenever we are going to clone any repository from LM. So it's recommended to update these repositories so that it's take latest updates which are not fetched through our command which have executed last two, right? So that will be updated. So it will update the packages. So it's saying successfully got an update from Prometheus company community. It's saying happy helming. So that's fine. So now what happened, we already cloned, and that is now to date from Helm repository to my this virtual machine, right? So this is done from mine. Now what I'm going to do it, I'm going to install this using this package. I'm going to install. So I'm going to do it, Helm Helm install. So the command is Helm install. You know very well that if you want to install any package, you need to use Helm install. Helm install. After that, I'm going to use Helm install. Then afterwards, I'm going to name that. Okay, what kind of deployment you are going to do for this? So I'm going to say that Prometheus stack. Okay, Prometheus stack, or that's fine. So it's stating that okay, this name you have given, but which repository you're going to use and do this kind of installation. For that, I'm going to test Prometheus community. Simple, copy and paste it. Okay, copy and paste it. Simple. Then afterwards, in this one, you have different stack files which are available. Cube Prometheus stack is available. Different things are there which I need to pass it. Okay. For that, I will explain because we require additional information before executing this file. Okay. So if you check over here, it's stating that Helm install Prometheus stack, right? The name Prometheus community which is existing on my virtual machine Prometheus stack, and I need to trigger inside that cube Prometheus stack. And then afterwards, I'm saying that this Helm installation should be done into namespace of monitor. Okay, so prerequisite is that monitor namespace should be available. So do I have that kubectl get ns? Yes, I have created monitor namespace. Okay, so that I'm saying that okay, whatever the installation you're doing for Prometheus and Grafana, that should be isolated into one namespace. So that I'm passing over here. And in the next stage, what in the Prometheus service, so whenever I'm going to deploy any application into Kubernetes cluster, so I need to expose that as well, right? Because end of the day, I'm going to use this browser to access Prometheus and Grafana, right? So by default, the service is a key pair which expose our application to browsers. Okay. So for that, we required one service. So by default, because this is written by Prometheus community, the chart.yml file, deployment.yml file, different type of file, because we are not writing the file. So what they have done, they have exposed this service for cluster IP by default. I will show you when I'm going to deploy this. You don't need to worry. So here I'm going to say that go inside this Prometheus service file and override exposing this service of Prometheus to NodePort, because when I'm going to access from the browser, we are exposing always NodePort. You remember in the last sessions also, when we are going to expose our application, we updated in the service as NodePort. Okay, so if I have any configuration file over here, so I can just show you that as well. So let me see, deployment, is there role binding, is there service, do I have service? Yes, I have service. Service, no, service deployment. Let me see, service target port, protocol target port is there. That file I cannot find currently, but usually when we are going to expose, we will expose through node ports. Okay? Node ports are application load balancer. Currently we don't have, because our application Kubernetes is hosted into kind concepts. Okay, Kubernetes in kind and on the virtual machine. If I'm going to deploy this into EKS cluster, at the time I'm going to update this with application load balancer. Okay, so here I'm saying default port number is 3000, 30,000, that is for Prometheus, and is even in the configuration file of service of Grafana, I'm updating to NodePort. Okay, type also NodePort, type will be NodePort, and the port number will be NodePort. Okay, these two already we have done in the previous session when we are exposing. So when I'm installing, we will update these configuration files which are available in Prometheus community repository, which we have fetched from what Prometheus Prometheus repositories, right? Sorry, Helm repositories. Okay, so as it is, I'm going to copy this and I'm going to expose. So if you check over here, I've written this also, that why we are using Helm charge being installed with this command, namespace installing into monitoring server. Here it should be monitor, no worry, monitoring namespace, I'm deploying this application. Set, I'm saying override the default Helm values. I mean this some by default it is exposed in the cluster IPs. So I'm going to override to node code. So what I'm exporting, I'm overriding two services, Grafana and Prometheus. If you have additional service, we don't require, because that is internal cluster matters, right? If you have some database connected to that, if you have any different services, right, that we don't require. So both services are now currently for the node exporter. So let me copy this and paste it over here. So if you go over here and paste it and execute this command, so usually it will take 3 to 4 minutes in order to install this Prometheus and Grafana inside monitoring namespace and deploying all the configuration file using Helm package chart. Now we can see that I can duplicate over here, and I will duplicate my session, sudo su, and I'm going to use it kubectl get pods, right? Get pods, get pods and hyphen o wide, and I will be adding watch, so that I want to watch what activity is going on my cluster now. One is processing for the setup. The second is already I'm going to watch it. So if you hit enter, you're able to find I think it's already executed, no problem. So what I can do it, so let me check. So it's already created. Okay, there's a reason that is not showing, but usually using this command we can watch what activity is going. So what I can do it, I can use kubectl get get pods, right, hyphen o. I'll be using wide in order to check that where it has been deployed. Okay, so it's saying there is no resources has been done. Okay, I have done this wrong mistake. Wide hyphen what, I need to pass what, I need to pass the namespace, right? So monitor my namespace. So if you check over here, see, let me just use it over here. See, now it's stating what it install. It install multiple Prometheus multiple tools, right? So in the Prometheus, you have alert manage, you have Prometheus Promo, Prometheus.0. Then we have Grafana stack. You remember that using the package I said we will be installing Grafana in package, and all the configuration are already predefined in Helm charts. Okay, so if you check over here, there is a one promoter, right? Prom operator basically is a one user which is created by default. Usually what will happen, you can access the Grafana using admin as a user and the password as a admin. Okay, admin will be there, but in this Kubernetes using Helm chart, this is written with prom operator. Okay, I will show you how we can fetch this secret as well. So here everything is going on, and if you check over here, it's stating that now if I'm going to just remove monitor, so that I'll be using watch, and I'll zoom and I will show you everything. Okay, before that, let me hit enter over. Let me clear all the screen, and let me unzoom and hit enter. Okay, so now if you check over here, you will be finding, see what has been deployed: 1 2 3 4 5 6 7 8 9. Okay, so now if you check over here, node exporter, how many times has it been deployed? It has deployed into 4 times. The reason is that why? Because docker is docker container, how many we have? We have four containers we have, right? So four container, that means one is what? Let me give it over here. So okay, see, one is installed, one is deployed into Kubernetes master, that is control panel. Three are remaining has been deployed into worker one, worker two, worker three. So how many nodes we have? We have four. We have this one configured using kind cluster, right? Here you have one kube matrix that is deployed for what? For monitoring our system matrix of Kubernetes. Okay, so let me switch back to my drawing which I have demonstrated over, right? So if you come over here, you'll be finding, oh yeah, see what I've said, that cube system metrics will monitor the control panel metrics. Okay, so for that what we have? We have this one, state metrics. Okay, state metrics I do have. Remaining these four are the node expert. That means whatever the activity is going on the node of four node, that is master one and three slaves, that all the metrics will be scrapping using this stack. So Prometheus on each node has been deployed. Okay? So if you check over here, it's stating on this. And if you check over Grafana is required only one only. So it may be deployed into worker one, worker two, depend on how our controller managed in our Kubernetes. Okay. So if you check over here, see, it's giving us where it is deployed. So let's cross check which I have stated. First is deployed where? First is deployed into control panel. Second is deployed into worker 2, worker 1, worker 3. That means four worker nodes has each one Prometheus node exporter configuration deployed onto it. Okay, so if you're confused again, so Prometheus, let me search over this Prometheus node exporter, right? So let me show over here what exactly I'm speaking about. So host machine with a node exporter. Using Prometheus, you can install multiple things on any worker nodes or any deployments. Okay, so Prometheus installation downloads. Let me click on this. See, if you check over here, see, it's the alert manager. This is already installed. So where are the alert manager? Where is alert manager? See, if you check over here, alert manager is configured. Okay, so we achieve one. We achieved node exporter, that will be done here, node exporter. So node exporter will monitor all your node activities. So using this package, what we have just specified, this is been packaged from Helm. Okay, so if you come over here, you'll be seeing that using node exporter and be deployed into a Docker multiple nodes. Okay, so that is clear from your point of view. Now the point is clearly, so how we are going to manage this. Okay, so before moving towards, let's read what we have actually done. So with this reading only, we are going to able to try to understand what actually this Helm has done. So Helm, what it done, it's created one stack, that is Prometheus stack. This name I have given, right, using this command Promise stack. Okay, so it's saying that is deployed version is one. You know, remember that in the last sessions we have discussed about Helm, how you can manage a rollback strategy with the Helm, upgrade and rollback. Okay, here is stating that if you want to monitor the pods, you can monitor using this command. So we already did. So it's saying that get Grafana. When you're going to access Grafana from your browser, you can use admin as a user, but to get the password of that, you need to pass this command. Okay? So it's already printing the command over here. So now it's saying that the password is a secret. So secret is what you remember that we already discussed about secrets, right? Kubernetes secret. So Kubernetes, whatever, it has inbuilt feature of secrets vault within the Kubernetes. So some sensitive information, that is passwords, API keys, or session token or token, this kind of things we can store into secrets. Okay, how we are going to get this? We can use this command to get it. And here is passing bar base 64D. That means this secret is encoded with base 64. So how I'm going to decode? Using flag D. So using this command, I can see what is the password of this. So I'm going to use over here, and I'm going to print this. Okay, so it will print me stating, okay, just a second. The space is coming out, no problem. So I need to go it over here because it's overlapping, right? So let me go it over here, hit enter. So see, password of Grafana is prom operator. Okay, so what you need to do, you need to open one more terminal and keep this as it is. Okay, it's saying that if you want to expose your pod name and different data, you can go with this. If you want to port forward also, you can port forward, because our application, our node exporter is deployed into worker nodes, and worker nodes is being handled from Docker container. So what we require, we need to port forward from Docker container to our host machine. This concept we already covered in the last sessions, right? Previous last session. So same concept we will be opting, and we are going to do that. So how I'm going to do that, that we will be cross checking out. Okay, before that, what I'm going to see, that let's see, what we have, right? Get all in the namespace of monitor. Okay, let's see whatever has been done into namespace of monitor. Here I can get the service, I can get deployment, I can get any PVC is created, different concept is created, everything I can get it. So let me clear and unzoom, and I will execute this command one more time. So click enter. So now I will zoom in, I will show you what exactly is coming. So it's saying that in the namespace, so 9 pods has been deployed, that's fine. Then a service has been deployed, that is 1 2 3 4 5 6 7 8. So 8 service has been deployed, service. So if you check over it, what is saying? Service. So in the namespace, pod are created, service are created, daemon set is created. Okay, deployment is created, that means using deployment only we deployed pod and daemon set, so you not get confused. Even we have replica set over here, desired one, current one, and ready one. Okay, so this also fine. We have stateful set app, that is alert manager. So remember, we already discussed about stateful set app. That means we don't want to lose any data, like say in the alert manager, if I'm going to configure any SMTP server or any data need to be collected, everything. So we cannot opt for a restarting of this alert manager to lose the data, right? So if one pod is crash, so the second pod will be created with the same name over here. Okay, so for that we use stateful set. So it is using replica set also, it will make sure that at least one pod should be deployed, one replica should be created. Okay, so if you check over here, daemon set. So then the question is coming over here, how node exporter, see, all these pods are created one, but node exporter has created four. So how does it handle? It handle with daemon set. Daemon set will ensure that in every available node, one deployment should be done of that application. That application was node exporter. If I'm going to add feature or scale my node exporter, then daemon set will ensure that fifth node should also have one node exporter to be installed. Okay. So it will check and it will install node exporter by daemon set. So if you check over here, 4 is a desire, because 4 are four work. There are the four nodes are available in the cluster. So that on the 4 also it has deployed our what node exporter. So these are the stacks which we have discussed up to now. That's all is coming in this project. Okay. So all are up to date and available also 4. So it's matching our desire what we have configured. We have deployed 3 worker node and 1 control panel. So that also is that's why it's deploying 4 nodes. Now coming to the point what we have discussed over here. So I've stated you that I'm giving updating some configuration and I'm going to override node ports with I have overwritten cluster IP with node ports. Okay, this we will cross check now. So if you come to the service, see alert manager is exposed to cluster IP. So by default, all was cluster IP exposed. Because I want to now in this project, I want to use Prometheus and I want to use Grafana from browser access. So for that, I'm instead of exposing on the cluster IP, I'm exposing through NodePort. Okay? So with this configuration only, I'm able to achieve this, or else it was not. I cannot access this Grafana and Prometheus from the browser. So for that, I need to override. So that's the reason it's coming over here, the IP address, and here also see I have given that it need to map on 80, right? 80 on the container port, right? Container port. Then here I have Prometheus where you have that is 9090. So Prometheus node exporter by default runs on by default Prometheus runs on 909090. Okay, so 909 also is there. That's we don't require it for alert manager. Currently I'm not covering alert manager. If you require, we also can do that as we can do this as well, but we will do it in the uh, our last end of the mega project, where I will be configuring alert manager and I will show you that whenever there is a metrics crossing out, we will receive one email alerts. Okay, so that we are going to cover in the later stage. So this is only monitoring and observability project. So now up to point of time, you have seen that what we have deployed using Helm chart. If you say that now, sir, without Helm chart, can we do this all time? Yes, we can do everything, but we require a lot of time and we require perfect configurations in order to deploy this from this Grafana into our EKS cluster. So what I need to write pod.yml files. Sorry, we need to write deployment configuration file. In the deployment, I need to mention replica set, I need to mention daemon set, I need to mention different things. Okay, so here might be three deployments. One is kube prom operator, kube state matrix, and one is Grafana. Okay, so this one kind of things. So we need to expose this. It will take a lot of time and efforts to do that. Okay, so Helm will support us to do this within minutes or hours. Okay, so now everything is done and everything is being accessed only within the cluster. But our agenda is to access this from the browser. That means outside of cluster. That means to the browser, right? So how we are going to do that? That we required one service, right? If you remember, with the service only we can access. So already I've defined service. So what I need to do it, I need to create a service. That service will uh, communicate with my API server, and the API server will interact with my nodes, right? Kube proxy details, right? And it will fetch all the details and it will expose to API server. Then I can find on my browser. Okay. For that use case, I need to port forward my services which is running on my client cluster. The reason is that because these node exporters are running inside the Docker container. So I need to port forward the Docker container to my host machine. If you are not running your Docker, your Kubernetes control panel and the worker nodes, different nodes on your Docker, then you don't require this step additionally, right? So because we are using kind, we require this step additional. If you are going in the future of EKS, we don't require this exposing part. Okay? Because EKS usually managed service from AWS. Okay. For the learning purpose, we are using this concept. So that's fine. Now what I'm going to do it without wasting time, we will expose our service what we have created. Okay? So for that, simply this is the existing command which we can use it. Okay. So let me explain you and I can even go with this concept. Okay? So which service I need to expose? As I mentioned that I need to expose two services. One is Prometheus, that is node port. The second is Grafana. So let's expose first Prometheus. So I'm copying this Prometheus Service, SVC stand for service slash Prometheus stack cube Prometheus. Okay, same I'm going to give it over here. Okay, then afterwards I'm saying that to be mapped which on which port number is working. It's running on 9090. So 9090 should be exposed to my local machine, a local machine of 9090. Okay, so because 9090 is vacant on my this EC2 instance, I don't have anything running on 1990. Okay, that's why I'm using. Okay, and even I'm spacing that this service is accessible and it is hosted in which namespace, in monitor. So I'm passing monitor namespace. Then where I want to expose, I want to expose this service to specific IP, that means me my home IP, or I want to expose for anyone globally. So globally web is 0.0.04, because I'm saying globally at the point of time it will be exposed to anyone, but that layer we can handle with EC2 instance security groups. Okay, if I hit enter, you're able to find that this has been forwarded from 9090 to 9090. Okay, hit enter. So I'm using emphasis, this and emphasis, right, where I'm going to run this service in background. Okay, if I'm not going to use this one, that will throw me stating it's printing all the logs. If I'm going to use control C, it will me exit. Okay, so for that use case I'm using emphasis. Okay, so here I'll not use emphasis, I'll show you why I have used as well, so that you should not feel that okay, why we are using this emphasis. Okay, the second thing I need to expose, as I mentioned, that I need to expose what, I need to expose Grafana as well. So service slash Grafana stack Grafana, this also I'm exposing over here. kubectl port forward service Prometheus Grafana, the same name which is over here, stack Grafana, and here is exposed on 80 port number, right, it's running on the 80 port number. If you check over here service, so it's saying 80 port. So 80 port is already taken. If you remember that while I have created this this kind cluster, I have already used 80 port. So that's the reason I'm switching from 80 port to my next available port number, that is 3000. The reason is that uh, 3000 is a default port number for Grafana. Okay? So for that use case, I'm using 3000. I can use any number of 3001, 3002, but 80 port should is a host port of my Grafana, so that I cannot change. I can change host port number. Okay. If I hit enter, you're able to find, see, it's printing logs now. So if I'm going to use control C, it will close my service. Okay, exposing service. So for that, I'm using emphasis. Okay, here enter, hit enter. So it is running in the background. How I can validate that? I can validate using network hook, that is netstart. So if I'm going to use netstart, it's stating that netstart is not installed. You can this command or Linux command and install my net tools. Okay, give me a second. Now if you check it over here, and let's check out on what EC2 is, sorry, what is running on my this virtual machine, right? So let me unzoom and execute this command again and hit, sorry, what was that, hit enter. So you're now able to see that, you're able to see that, and give me a second please. Okay, you're able to see that, okay, I have forwarded kubelet. See, this is the one which I forwarded, that is running on 9090, right? This is Prometheus, and 3000 is for Grafana. Okay, so it's kubectl. I use kubectl command, right? So it's printing the program name as kubectl. Okay, so that means it's running in the background. So I have the successfully working on. So now if I want to access this, I need to open this security groups, right? So I'll be switching over here. Then in the instance, in the security group, let me go to the security group. Where is security group? I need to open firewall inbound rules, right? So for that use case, I'm going to open one security group. In the security group, I need to add this as well. Okay, I'll be editing inbound rule. Here I'm going to add custom 9090 for Prometheus and 3000 for Grafana, right? Grafana. Here I can go with this one, I can go with this one. Okay, I will update save rules. So here I'm going to take the IP address of my virtual machine, right? EC2 instance basically. So what is the EC2 instance IP address? This is the IP address. Now I'm going to go over here and first thing I'm going to access my Prometheus. Okay, so hit enter, you're able to find that Prometheus is accessible by browser. One thing you need to understand, this configuration which I have done, it can be accessed by anyone using IP and the port number. So in the real-time production environment, we are going to add username and password protection for this. But because this is in the learning stage, we don't require it currently, okay? But in the real time, you are not exposing to everyone. We will be passing the username and the password. Who are going to pass the username password correctly, then only you are able to successfully into login into Prometheus. Okay, so if you check over, Prometheus is done. Now if you check over here, Prometheus by default has GraphQL, where I can go and add the query in order to check the data which is collected by Prometheus, and I can use any query to check take the output from there. Okay, usually that is promo there is one database as well, and this Prometheus using one query language, that is let me just uh, take Prometheus, where I was in the Prometheus. Let me see, Prometheus query language. Okay, so no, not this one. Sorry, Prometheus query language. Prometheus query language, right? See, PromQL. So basically, Prometheus use PromQL like query language in order to fetch any data which is stored into Prometheus database. Okay. So these concepts are there. So let me go and see what I have done it, where I was accessing. I was accessing this one, right? So this is done. So now if you check over here, this one. Now the point is there, what we are going to check. By default, we have installed multiple things over here. So how we are going to see that? So if you come over here, you're going to see the target health. You can see rule health. We can see service recovery. So if I'm going to check target health over here, you're going to print all the targets which are written into configuration files. Okay, so this was defined by the community of Prometheus. Though already they have added one Prometheus.yaml file will be there. In that file they have all the configuration written. So what we are what we are going to monitor over there. Okay, so if you check over here, it's monitoring the alert manager, config reloader, http request, right, container code DNS, http metric, kube system namespace. In this namespace is labeling endpoint, this kind of things, right? So it's, if you check over here, different type of data is scrapping from my Kubernetes cluster, right? So if you check over here, some are down as well. Okay, so some are down, that is not is saying that is refused to connect to this error. That's fine. Maybe some issues that you can fix it in the real-time environment as well. Okay, but if you check over here, there are the multiple data is being collected. Okay, so if you check over here, these are the services working on. If I'm going to check over rule health, so if you check over here, so it's printing now. Alert manager failed reload. There are the certain rules. Alert manager cluster down. So these are the configuration cluster written by the Prometheus community, right? Which is Helm Prometheus community. So these are doing, but we are not going to receive currently alert manager. The reason is this: I have not configured the alerts manager. Okay, if you check here, the alerts are there, but alerts I have not configured, right? SMTP server is not configured, so I'm not going to get this alerts now. User, these are firing stages. Firing stage means this service is not accessible currently with this monitoring concept. At this time we're supposed to receive emails as well. Okay, but currently we don't require this, but in the real time we will receive stating this service is not accessible, please go and look into it. Okay, this kind of things. Now the data which we are collecting, right, this cube state metrics, Kubernetes app, Kubernetes pod crashing, Kubernetes pod not ready, this kind of things we can monitor everything. See what are the best practice, best solution they are providing, like monitoring. If some pod is crash looping, we will receive update. pod is not ready, we will receive a deployment general mismatch. That also we can have. We can monitor replica set. We can monitor waiting container daemon set not scheduled. Why it's not scheduled? Because our nodes might be tainted, right? The tainted, and we have annotation, we have given wrong annotation. So it can be any cause of errors, but everything we can monitor with Kubernetes, with the with collaboration with Grafana. Okay, resources, see, cube CPU overcommitted, resources almost full, quota almost full. So this will provide you n numbers of monitoring your complete cluster cluster resources. Okay, so how beautiful is it? If I'm going to write this, it will take days of writing this configuration file, but using Helm, I have done it within minutes. Okay, so now we can read this, but this is not the best practice. We required any time series dashboards. Usually when we are going to present to anyone, we are presenting through dashboards. Okay, for that use case, how I'm going to access the dashboard? For that, I'm going to go over here and I'm going to access my Grafana. Hit enter. So I'm into Grafana now, because Grafana already I have done port forwarding, and even I have enabled into EC2 instance security group 3000. So Prometheus, sorry, Grafana icon is pinging now. It will throw me to login page. Welcome to Grafana. Now by default, when we are installing outside of Helm, so the password and the username both will be admin. Okay, if you're not aware, if you check my channel in this videos which I have done multiple projects, they have already differentiate. I have given the demo stating by default it will be admin, but because this is written by the community of Helm, from this community, so they have overwritten the password. Okay, how do we are going to get that? So that I'm going to show you that as well. Okay, so for that, let me see. Okay, Kubernetes cluster. Okay, here is the one, right? So it's basically thrown me before only, right? It has stated me stating by you take this command and execute it. Okay, so this is a command which I have used. So I'm saying that okay, kubectl namespace monitor get secret, get the secret which is available inside which monitor namespace, and for which prom stack grafana -o json path, and this is a root where it is there, and it should be that means this is encoded, we need to decode this. Okay, so I'm passing this command, I'm going to get printed. Okay, if I'm going to pass again this command, so it will print me same password. So I'm going to take this password and I'm going to paste it over here. Okay, login. If you're able to see that the successful, I'm able to log in now. Okay, so this is a dashboard of Grafana. So let me parallelly open the Grafana lab, which is the official website of Grafana. Okay, so you find over here Grafana. Okay, grafana.com. So now Grafana is open source. So now if you check over here, when you see over here left side, it is the home, bookmarks, start, dashboards. If I want to create any custom dashboard, I can create any dashboard over here. Drill down, alerting, even we have alert mechanism in Grafana as well. In Prometheus, they have alert manager. In Grafana, we have a separate mechanism of alerting. We can configure both ways. Connection, when I want to link this with different concept, when I can go with the connection. That means if I want to add any data source, right? So by Grafana, by default, Grafana will support different type of data scraping applications. Google Analytics, Adobe Analytics, Alert Manager, uh, Amazon Aura, Amazon Antenna, right? Uh, AWS IoT, Azure DevOps, right? Some are in the enterprises level, some are in the community edition. Currently, what we have installed is Grafana Community Edition, that is free. In the organization, we will install enterprise version. At the point, this everything will be free. We cannot use currently for this, right? So everything will come to free. We can use it. Even we can integrate Jira with the Grafana. Okay, Jenkins also we can integrate with Grafana, but Jenkins comes into for this, but anyways, no issue. So data source, if I'm going to go for data source, I can add any data source over here, right? So this is Grafana, Core, Flux, Loki, Elastic, Jagger. These are the data scraping servers. Okay, so they will store, they will collect the data, and it will scrap in the data source. I can use different data source. Okay, so now if I'm going for SQL, I can go for Prometheus. Here I have one exporter for, I think, for MySQL. See this, I need to install this if I'm going to go for MySQL database. Same if I'm going with the Prometheus, I need to monitor my uh, Postgres database, right? With the Prometheus and Grafana, I can install that as well. Okay, Postgres data source. So these are the different data sources we can use. Even every application supports user management, so there is nothing new. So in my sessions, all time, every time I say that application without user management is nothing. It is not real time application. So here also you can create multiple users, and you can create authentication. You can add a multi-factor authentication. You can share with your teammates. Okay, you can apply roles as it to have least privileges to that user. You can specify to different dashboard. Even you can specify over for the global role of this Grafana. Okay, so now the point is that we already have this connection. See, if you go database, so it's stating thus alert manager and Prometheus is already configured. This I haven't done. If I'm installing Prometheus and Grafana independently without Helm, so I need to do this manual step because I use packaging manager. So all configurations of Prometheus and Grafana integration was done successfully, and it has been embedded into data source as well. So if you check over here, it's already added to data source alert manager and Prometheus. Because I have not exported alert manager, so it's not, I cannot use it currently, but you can use this as well. So here Prometheus is there, so that's fine. Now coming to the dashboard, what I can do it, I can create multiple dashboards. Okay, coming for home, if you check over here, create dashboard, you can find it anywhere. Here I can click new dashboard, right? So here I can import a dashboard, click on this discard. So if I'm coming over here, it's stating that if you want to add any new data dashboard, right? I'd say that I want one Kubernetes dashboard. So what I can do it, I can write my customized dashboard using JSON format. Okay, or if I file I can update, or I can use Grafana dashboards which are provided by Grafana, and just I'm going to give the ID of that, and I'm able to clone that board inside our Grafana server. Okay, so let's add Kubernetes. So it's printing me multiple dashboards which are required. So let's go with the KS this one, or else let's say which will look us better way. Kubernetes dashboard. Ingress we are not using, so I can go with this one only. So what I'm going to do it now, I'm going to use this dashboard. Okay, so I'll click on this. So let's say how I can add this one. So here it's saying that, okay, if you want to import this dashboard, download JSON file. I can download JSON file and upload over here, or you can even use only the ID of it. Okay, so what is the ID of it? The ID, what is there, the ID? So I have copied, so it's not printing me over here, but I can paste it over here, so it will print me now. So see, it's into 15661 is a dashboard available into grafana.com. So I'm going to say that load, no, not load, just a second, load this one. So it's importing that one. It's saying that, okay, KS dashboard name is there. Okay, that's fine. So it's saying that which kind of data set you need to use in order to get the matrix and display on this dashboard. So I'm going to select, I have default use, this is done by Helm as I explained. I'm going to use this and click on this import. As I'm going to click on this import, my dashboard will be created. See how beautiful it will look. See, I'm going to display it visually. See what is there? I can monitor all the nodes. How many nodes do I have? I have 4 nodes. See here, it's printing me that. So whatever I have cluster control panel, worker node 1, worker 2 node, worker 3. I can monitor one control panel metric details, or I can monitor all my nodes. Then in the microservices, I can monitor alert manager, code DNS, Grafana, proxy. This has been installed from what? Helm community of Prometheus, right? Which we install. It's saying that which pod you need to install. You remember these are the pods which we have installed, right? Into the namespace of which namespace? In the namespace of, I'll show you the namespace also, monitor. Okay. So in the monitor namespace, how many ports I have? I have this many ports. So all ports matrix I can check. Even I can select selectively. So this is for maybe let's say for control panel. This might be for the worker node. See in the worker node one, what I do have? I have total number of 4 nodes. Three are worker. Total 24 pods have been deployed. 10 workloads, this all there, asim cluster, cpu is there, what ram is using, cpu request is there, how much is done. So all is done over here, right? So this all is printing me all the details. So how much data is transferring, this is giving me all this things. Okay, in the nodes monitor namespace, let me give it container name is all, that's fine. So how many pods I have, just a second. In the monitor, let me give it nodes, that's fine. In the pods I will give it all, right? So in the odd C, in the monitor namespace I have how many total pods 24, nodes all, that's fine. On the all nodes, pods all, cluster all, monitor namespace, let me refresh this. Yes, there are the 4 nodes and 3 are worker nodes. One is control panel. Okay, if you check down over here, it's saying to pod number and the nodes are there. This is a pod number, this is upper limit, this all there. Okay, so we are about 5. This specific memory consumption is there. I have worker nodes, worker 2 nodes. So how many ports overall I have? I have 10 is working in the control panel. I have 4 in worker nodes. I have worker 6, sorry, worker 1 I have 6, worker 3 I have 4. Okay, so now cross check how many pods do I have in the control panel. So let's check over here, kubectl get pods in the namespace. What was the name they have given over here? Let's no, let's get it pods. How we can get it? Let's say in the namespace, let's give it namespace of monitor. Let's cross check with this only, monitor, right? Kubectl monitor hyphen o, and I want to see on which it has schedule, right? So let me see over here. See, the worker node 1 has 3 pods, right? 4 pods are running, right? 1 2 3 4. Let's go and check over here how many pods are there over. See, if you add worker 3 has 4 pods. Okay, worker 2 also has 4 pods. So whatever the real time is coming up, that is printing over here. So there is nothing issues that you can do every single things over here. Now the point, we have created one custom dashboard. Even we can write this from the scratch using any AI tool, or there is a different blocks available from Monitor. But now the point is coming up, sir, why you use dashboard? Because already by default Helm, when you install using and deployed our Kubernetes and cluster, sorry, Grafana and Prometheus, so by default it has created different dashboards. Okay, so if you check over here, there are the different dashboard has been created. So this configuration files also exist in the Helm charts. Okay, so if you check over here, see it's giving every single, this one I have done now just before, but if you check over here, this all are done. Okay, the scrapping also done by Prometheus scrapping this all states over here, and it is passing to this one. So now I want to monitor only the pods of the namespace. So this dashboard I'm going to over here, then I'm going to click on monitor, so I can monitor over here. See, CPU is dropping over here, alert manager, memory utilization 300%. This all stack is available. If I'm going to go for different one to check out the cluster, so in the cluster, networking cluster or computer resources, no, let's say we'll go with the cluster only, right? So if I'm going with the cluster, you're able to find, see, in the cluster is default Prometheus, right? So you're able to find the data transferring between the cluster and outside of the browser, because we are accessing Prometheus Grafana from outside of our cluster, right, from the browser. So this is showing the data transferring, rate of bytes there, how much load is coming, bit point is coming, all these details will be coming up. Okay, so now the point of time we have done this is to monitor our pre-built configurations. Okay, how about when I'm going to configure and monitor our application? So for that I need to deploy one application, right? So for that use case, cube system metrics is done. Cube system, that metrics is done, but I need to have the metrics of real-time application deployment. Okay, for that what I can do it, I can go and there is a one application which is kind voting app. Basically it is created using different stack. Redis is done to collect a new vote. Redis is used as a cache to collect the data, right? .NET for Progress as a Postgres as a database, and Node.js as a front end for this application, right? So for that use case, front end is written in Python and different web app is written. So multiple stack has been used for this application, and this work is done by this person. This all this applications rights goes to this person who has created this repository. Okay, so who is the one? I'm not sure what is the name of it, but there are the multiple contributors for this. Okay, so we are cloning his project and we are trying to deploy into Kubernetes cluster. Where are the configuration file? This is in k8 specifications. Okay, so you can copy this URL and you can do everything. Okay, so by default, if you check over the architectural diagram over here of this, so you're able to find this application usually take the data, right? So if I'm unzoom, it's whenever we are going to vote, it will push the data to Redis, the worker, and it will store into a DB, and the result I can use one more service. So in here we have two services, that is vote and result. So we can run vote and progressively we can see the results as well. Okay, so if I'm going for this, there are the multiple configuration file. So for here I'm going to go and clone this one. So simply I'm going to copy this and I'm going to go outside of no, let's go inside this what we have created, or we can use it git clone and execute this URL. Okay, hit enter. So you're able to find that one directory is created. Okay, so ls you will be seeing one directory is created. I'll be going over here, find. So ls over here you have different files. So if I'm going in the configuration files of uh, k8 k8s specifications, okay, here are the custom configuration files are available. Okay, so if you check over here, there is a deployment.yml file, redis world.yml file. If I ls, or let's say ll, so that I can have ll. Okay, see, DB deployment is there, DB service is there. We are creating the DB, deploying database. The data is what we are using, Postgres database. To expose that, I'm creating service. Redis, I'm going to deploy. I'm creating service to integrate within our application. Here's results are there. We are exposing this to outside of the. So what we are exposing? We are exposing results and vote. If I'm going to cat results, you're able to find the result.deployment. So what actually the deployment file looks like. So this is the one deployment I'm making it, version API 1. Okay, app results, name I'm giving result, replica set I'm giving only one. Okay, I can add multiple as well, but currently it's one required. So here I'm going to take this image which is available, and even this image is given by this provider, right? He's providing open source, so we are very thankful for him to provide all the details. Okay, so here see container port is 80. Got it? So that means our application is going over here, right? So if I want to expose and see what the service look like, okay, so results result service dot YAML file. So here see it's exposing into NodePort. So this only we have done for our Prometheus and Grafana, right? I have showed you, sometime we need to access our application, so we need to expose to NodePort, not cluster IP. When I'll give the example as well. See, the one which I'm going to access, that is exposed to NodePort. Which one I'm going to access? Vote and result both. Okay, but I'm not going to expose DP to my outside world, right? So how does it look like the configuration file of DB now? Okay, so DB service, let's see what will be there. So see cluster IP. So when I'm going to expose my application, whichever application do I have to outside of the world from the browser, then I will have to go for application load balancer on NodePort. Okay, you got it. When I'm going to constrain that some application within the cluster access, that I need to go for cluster IP. That means database always should be accessible within cluster only. We are not exposing to outside of the cluster. Okay. So these are the configuration files. So what I'm going to do it, as I mentioned that I'm going to apply this. So what are the command? kubectl apply, and even let me show you this. I missed out deployment, word deployment. So here if we check over here, I don't have specific namespace. That means it will be installed in deployed into default namespace. Okay, so that is to be clear. So I'm not deploying any into monitoring namespace or different namespace. It will take some time. If I required any specific namespace, then I can do that as well. Okay, kubectl apply hyphen f, and I'm going dot. That means whichever the files are available with YML of configuration file stored inside create a specific directory, all files to be updated, be executed. So what is printing me? Deployment is done, service is created for that, deployment for Redis is done, service is created, result service is done, one service is created. Okay, so microservices, and we are exposing the services. Okay, so now if I'm going to use kubectl get pods in the namespace of default, you able to see that there are the specific pods are running. DB, Redis, result, vote, and the worker. So these are in the worker, these are in the running stage. That means is deployed successful. So when I want to check it out where it is deployed in which worker node, so I can see that as well. So let me unzoom and hit enter, then I'm zoom. So it's stating that DB is deployed into worker node 3, Redis is deployed into worker node 3, and votes are deployed into worker 3. That means the load on the worker 3 should increase. Okay, so let's go and check over here worker node, where do I have? Okay, so let me go to the dashboards, nodes, worker nodes over here. So let me see compute resources, worker loads, compute nodes, right? Nodes. So click on this. So here I'm going to remove and nodes worker 3. See, you're able to find that the worker load on this one is spiking up, right? So this is the find. You see this is 29% memory is taking, 27 memory is taking, Redis is installed, DB is installed, Word application is running. So these are done. If I'm going to use a replica set, then it will distribute and deploy into different worker nodes. Okay, because replica set I mentioned only one replica. Okay? That means one pod is created for that. Within that our service is running on this. How do I access that? Want to use kubectl get all, it entered. So you're able to see that all in the default no space I'm getting all the data, like pod is created, like 5 pods are created, 5 service are created, 5 deployments are created. First deployment will be created with the deployment kit, replica set is mentioned, one desire, one current, one ready, and service with the service I have export service using service.yml file. Pod is created with what? Deployment file, and replica set is created with deployment.yml file. Okay, so this is the reason we have all this one is exposed. Now if you check over here, this is 2 are node ports and 3 are cluster IP. That means I can access only these 2 service only. So what I need to do it, because my Kubernetes cluster is installed into client docker, right? For this use case, what I need to do it, I need to port forward this as well. Okay, so on which port number is running? It's running on 5001 is a service of result. Vote service is running on 5000. So what I need to read, I need to expose. For that I have the same command which I have used before, right? So simply what I'm going to do, I'll take it over here, again, port forwarding of this, and I'll be taking port forward service, right? Paste it over here, and I'm exposing. So port forward service name, what is the service name of this? Vote one. And what is the port number? 5000 is running, and on which host number, port number, I'm going to map it with 5000, because 5000 is vacant for me. Okay, if this one I cannot change, host machine, sorry, this is container port, I can change this one, but my 5000 is available, that's why I'm not changing it. If I want, I can change it. Hit enter. So it will again, it will progressive logs will be printed. So I will be use mffs to run this service in the background. So it is created, port forwarded 80. Okay, so again, I'm going to expose this vote as well. So for that, I need to go it over here, and here 5001 is there, right? If you check over here, on which port number is running on for 5001. So I'm mapping with what? 5001. Okay, so here which service I need to expose? I need to expose results. Okay, so if you check over here, results and note only are the node exporter. Okay, node port, give it over here, result, t is missing, I think I haven't given T, so I need to copy this. These two service I'm exposing. I have given namespace default because it's running in the default. If you don't give namespace also, there is no fine. But for the best practice, I have bit it, so I'm giving default. Hit enter, so it's stating that this also being perfect. Now to cross check, okay, sir, this is, you are saying that our service is running in the background and the host machine port number is mapped. How do you check over here, right? So if I check over here, see, there is a two new port number has been mapped. kubectl with kubectl only have mapped. That is 5000 and 5001. That means one service is running for my vote and results result services. Okay. So what I need to do it, I need to go again into my uh, firewall. I need to go into the inbound rule. I need to enable these two port numbers so that traffic from the browsers can be hit to my EC2 instance on which my Kubernetes cluster is running. Okay, 5001, right? So it's over here and I will update it. So let me cross check. This is 5000, 5001, right? What is that? 5000, 5001. So now what I'm going to do it, I'm going to take the IP address, which is over here, and I'm going to give it 5000. Okay, hit enter. So you're able to find that one. This you can use IP address I'll be sharing over here. Please try to access this one through the browser. Okay, so just go over here, just hit this one and try to give your vote. So basically it's a small application which is running over here. Okay, so I'll be pasting what I'm going to do it. I'll be giving the vote to cat. I love dog. I love dog. No, I'll give in I love cat. Okay. So this cat, what I have given. So if I'm going to copy over here and I want to see the results of it. Okay. So hit enter. So you're able to find the results. So results prints me what actual the data. See, is printing cat. So can you guys uh, change your answer? Go over here and give the answer to dog. Okay. So let's see what will happen. It will have 50-50. That means I have given dog and Anshul has given for cat. So it will be real time data will be fetched over here, right? So how many votes I do have? Two votes. See, so Anshul might have changed his answer now. So that means it's coming two. Even I can open into private, any private window, right? So private window, I'll open it and I will give my vote from here as well. Okay. Continue the site. That's fine because I know I'm giving cat. Okay. When I'm giving the cat, let's see what will happen. So results are 3. See, the rates had been done. So if I'm multiple user, they are giving their votes. So dynamically will fetch all the data that has been stored into progress Postgres database one table, and from there it is displaying me the current progress of the voting. Okay, so this is how one. But now if I'm going to see that, let's say randomly what happened, we are giving some load on this, right? So let's see what will happen on the Grafana level. So what I'm going to check it over here, instead of nodes, let's go and monitor something else. Okay, so what we can monitor, we can monitor the resource networking, right? So where are the networking of the pods, right? So if I'm going to click networking of cluster pods workload, networking of the pod, which are the pod I'm going to use is monitor, right? Monitor one. So you're able to see alert manager. Why it's taking alert manager? Stack node exporter. I'm going to take it. So here you're going to see it has been spiked. Okay. So that means whenever somebody is accessing from our browser, that means that real-time data will become. So in this case, let's say assume that our streaming application is there where we are streaming one movies which is latest release. So at that point of time, we can check it out. Okay, in the monitoring namespace on the specific pod, this kind of bandwidth is increasing. That means the traffic is coming to this pod. Now, in the point, I need to monitor the node, which node is getting higher load. That also we can monitor with the node one, right? So let me check where it is. Networking load, workload namespace, volume, workload cluster pod. Let's say node exporter. Let's see on the net exporter. Not this one. I was using, just a second, I can check that which one it is. Anyways, we have one custom also, right, which we have created. With this I1 we can cross check. Okay, so cat nodes, I want to check because my node on which node is it deployed, which node it is deployed. So that's fine, this is running in the background. Kubectl get pods in the namespace of monitor, and I'm going to give it a hyphen o and the white, hit enter. So now let me unzoom and hit enter again. So now it's stating that, okay, so Prometheus node exporter, yeah. What I missed out names. Okay, sorry, I've used wrong one. It's supposed to be namespace of default because the application is given deployed on default, right? So default namespace, if you hit enter, you're able to sign that three pods has been deployed into where? Into worker 3. So voting is coming on worker 3. So let's monitor the worker 3. Okay, so worker 3 node, that is worker 3, you able to find, see the network has been spiked because I have given three, what I have given three votes. Now if I'm going to go and open that same link now, which I have just shared, right? So if you unsure, can you put some load on that as well? So open this of voting into different private windows so that I need to increase the load on this. Okay, just randomly I'm giving the cat, I'm opening one more, so that might help me over here to increase the load. So can you please create some load on this manually so we can check real-time data what is happening. Okay, so I have done this and I want to go and now check it what's happened over here. See, did you find this? This is going in the high level. Okay, CPU 1 memory is this case, 8 GB memory is allotted to this one distribution memory, and you're able to see that network is coming. Let me refresh. It will take some time. CPU memory workload 19, that's fine. It's going slightly up. it is going with the slightly up memory consuming. So this is how we can create and we can monitor everything. Even no, sorry, I have given namespace wrong over here. So I need to go see, it's over here. You got my point. Intentionally what I've done, just let me give it 5 minutes metrics. So you're able to find that, see, it has been spiked. When I've created, it's gone down because I voted and opened my service into different private windows, right? So it's stating now worker nodes namespace default on this one, and what as microservices has been deployed. So if I want to filter also vote, you're able to find some of this metrics. Let me refresh this. So it's coming, see, spike down. So this is how we can have real-time monitoring, and we can take the action in case of horizontal pod auto scaling or vertical pod auto scaling, or even we can add multiple nodes if our load on our application is getting high. So this is how using different organization is using Prometheus and Grafana in order to have real-time data calculations, and what is a real-time uh, load is coming on the cluster and different namespaces, different concepts. Okay, so for that use case, you can go with this concept. You have different dashboards. You go with every single things. Even you open Chat GPT. Okay, so let's open Chat GPT. Open Chat GPT and give them the question over here and take the answer from there, stating that let me just open this where I am, right? Core DNS dashboard. So ask them, what is core DNS Grafana dashboard for K8s, uh, right? Why, how it is useful. Okay, useful, so that you can go completely with the documentation and try to understand what does it provides. Okay, so if you check code DNS, a default DNS server, Kubernetes deployment, what is it will give you all the insights of this specific dashboard. So code DNS dashboard is a visual monitoring interface built in Grafana. That metrics is collected from core DNS via Prometheus. So what I can monitor from there, DNS query rating limit I can cache, I can check, I can query rating and latency limit. That means how much rate limit, I mean how much latency is coming up, mix ratio, response of the coming request on the specific core DNS, how much is passed, how much is failed, success rate I can cross check, top query I can check, everything I can cross check. So now this has been given as example, right? So if I've opened here, this has to be displayed now. See, it's giving like this, how much request I have done, what request is done, so how much request is coming on my application. So it's in like this because we have opened for application on the browsers, right? So how much is the request is failed, nothing is failed. So if it is failing, it will print you somewhere over here, cache, see, cache content, cache size, right? That means if I'm going to access on my browser, the Redis used for the caching concept. Okay, so why Redis is used, so you can, Redis is used for, we have deployed Redis, right? So basically the Redis is a cache. Okay, remote directory server, Redis faster in memory database, so it will cache some of your content. So that is showing everything over here. So with this concept you can have all the insights, and I recommend you to go to the all the dashboards and use your assistant as a chat GPT and ask them with this dashboard, with this Prometheus API server, metric scrapping, what data I can collect, how it will be help us as a DevOps engineer, so you can do it all you by your own. So everything you have done, if I'm going to go with the scheduler also, it will see how much scheduler is failed, how much is passed. So currently I don't have any scheduler available. So Prometheus instance, let me click this. So it's showing that there is no scheduler is pending because it's all the ports are scheduled. In case one any pod is failing, it is for pending for schedule because all my nodes are tainted. At that point you may be finding that this is pending for scheduling. Okay, so this give you versatile options with the Prometheus and Grafana contribution. So this is our end of session for our integration. Whatever the resources you have used, you can delete by using the command. So you can use Helm uninstall the name of this one, and even you can uninstall your application. You can delete your cluster. All you can do it by your own. You have the document further, or else if you are facing issue also, you just delete your EC2 instance after this sessions, because it is T2 large, you will covering some charges upon that. Okay, so practice this 1 2 3 time and try to deploy this. If you're facing any issue, create one more virtual machine and try from the beginning. Okay, because all the steps have been given over here, there is no failure rate should be done. If it is something that you have missed by something, okay, so try to do it everything. If you find any something, you can revert back to me. Okay.